Good day everyone. We will discuss about DTA index recommendation pitfalls and problems with select star in this video. Let's get started. I'm going to use JBSWiki for this demo. I'm going to create a table called Table3. This is going to take some time, so I'm going to pause this video and then I will resume it once it is completed. It took close to 24 seconds. This table 3 has got a cluster index on column 1 and then additionally a non-cluster index on column 5. There are no included columns, just a non-cluster index on column 5. Let's enable the statistics time comma IO on and then let's try executing this particular query. Let's enable the actual execution plan and then execute the query one more time. And then if I look at the execution plan, what I'm seeing is like we are performing an index seek on table 3. And since we have just this non-cluster index on column 5 and this select statement has got a select star, it basically has to scan through column 2 to column 7. But since since the column 2 to column 7 is not present on this cluster index, the query optimizer has to basically get in touch with cluster index, which in turn performs a key lookup that basically scans through the table and gives you all the details. So now, if I look at the statistics information, what I'm able to see is like we are performing close to 20,160 logical reads. And then if I look at it further, let's look at how much time we spent. We took close to 63 milliseconds of CPU, and then 373 milliseconds of execution time. So what we'll do is like we will check this query in a database engine tuning advisor and then see if we are getting any index recommendation. I will leave all the defaults. I will leave all the settings as default here, and then let me start the analysis. We have an index recommendation. And what we are able to see is like the estimated improvement is close to 96%. So it seems like a good recommendation. So let's copy that and then try creating that particular index here. So what we are able to see is like the DTA is basically recommending an in non-cluster index on column 5 comma column 1. We already know like column 1 is in does have a cluster index, and then an include column for rest of the columns here. Yep. And whenever we use DTA, it is always good to check if there are any overlapping indexes. For example, in our case, ix_test1 is on column 5. So there is high possibility we can modify this. But just for this demo, we will create this index. I'm not going to change the name also. But if it is going to be a production, it is always good that you follow the naming best practice in your environment and change the name accordingly. But in here, I'm not going to change anything. I'm just going to create the index here. Once this index is created, let's execute the same query, and then let's see like what is the resource utilization and things like that. So let me execute the query one more time. Now, if I look at the execution plan, we no longer see that key lookup. And if I look at this one, we are doing a perfect estimate. And let's look at the details here. So what I'm seeing here, we are no longer doing 20,000 logical reads, but we are doing just close to 900 plus reads this time. So if you look at it here, and then let's look at the CPU time and things. So we have this one here. So if we compare it with the previous execution, what we are able to see is like we have an 20 times improvement as far as the logical reads are concerned. After I created the index, what I'm able to see is like the logical reads have come down from 20,000 to 946. But the CPU time is like increased by 15 milliseconds. And the elapsed time, that is the execution time, has also come down close to like maybe 84 milliseconds is kind of saved. So this is the index that we created. Now what we'll do is like we'll check the table size and then see what is the table size. Table 3 is the one where we are running the queries and things like that. And what I'm able to see here is like the data size for table 3 is close to 1.2 GB. But the index size seems to be close to 1.3 GB. It seems like the index size is more than the underlying data, which is really, really not good, because if your index is very huge, then it's going to have an overall impact. That backup size is going to increase, your maintenance is going to increase, and also like the database size is going to increase, which is not good. So what we'll do is like now we know like we have created a non-cluster index that basically covers all the columns. Yeah. So what we'll do is like let's look at the table structure and then see what is different. And what I'm seeing is like this particular table has columns from column 1 to column 7. And what is standing out is like this particular column here, which is column 2, and we have an bar car max. That seems to be like one that is standing out when compared to others. Everything else seems to be like kind of little okay, but this one column 2 is like a bar car max. So what we'll do, we will remove that particular column from the index that we have created. So if we see here, the one that we have created basically has this column 2. And now what I'm going to do is like I'm going to use drop existing on, and then I'm going to remove that particular column. So let's create this index, recreate this index, and then see what's the performance now. So let's go back to this, and then if I run it, the query is completed. So right now, what I'm seeing is like we have an index seek followed by a key lookup. But if I see here, what I'm seeing here is like this time we are not going for the index that we have created. So if you see here, the optimizer is no longer going for a DTA index, this particular index. Instead, it is basically going for this particular index, and that is evident here. If you see here, it is basically like going for IX underscore test one. So the problem is like, since column 2 is kind of removed from this particular index, the index that was recommended by DTA, the optimizer feels like instead of performing an index seek on this particular index and then performing an key lookup, what it basically feels is like it is basically thinking like it would use this particular index, which is IX underscore test one. So let's run this query one more time and then see if there is a change. If I see here, it is still going for IX test one. So what we understand is like for this particular query, column 2 seems to be very much required. So what we'll do is like now that we have removed that from that index, let's look at the size of the index now. Now, if we look at it, it is no more 1.3 GB. The data size is 1.28 GB, but the index size has come down to 93 MB. So that particular column 2, when we have added it, it seems like it is increasing the index size at least by 1 GB. So now what we basically have to do is like we need to check with the application team and then see if we actually require the star here. Do we actually need all the columns on that particular table? That is the question that we need to put in. And what the understanding is like after we talk to the application team, it will be pretty much that none of the application would require all the rows. There can be some corner cases, but we need to put that question forward. And then let's consider in our case, the customer or the application team is telling like we don't need all the rows, we just need only one column, which is column one. So it is same as the previous query. The only difference is like I'm no longer using star. Instead, I'm going to use column one. So let's execute that query. And then if I look at it, it is basically utilizing ix underscore test1 index. And then now if I look at statistics information, I'm no longer doing 20,000 or 900 logical reads. Now I'm just doing 19 logical reads. And if I look at the resource utilization, the CPU utilization is nothing. And also the execution time is 83 milliseconds. So the understanding for this video is like always talk to the application team and then check if they require all the columns as far as the select query is concerned. How much we can reduce, for example, if we can remove the unwanted columns from the select list, that is going to really improve your query performance. That's it for this video. Thanks for watching. Have a great day. Jai Hind.